Okay, so this is a continuation of our video. There was already one about how to enter the data into this table. And then there was, in that same video, we talked about how to use Desmos' capability to get the line of best fit, also called a linear regression. We identified the R value in here, and then we also identified the slope and the y-intercept of this line of best fit. We also talked about exporting or being able to use that equation differently. So we wrote one that is maybe easier to manage with less decimal places. So that video is already available. You can check it out if you haven't seen it. On this one, we want to identify ways that we can use this line of best fit to give us information. Since this R value suggests that this is a really strong correlation between our data, it also suggests that this line of best fit will give us reasonably accurate information. This data is mileage in thousands of miles of a car in the X list and the price that it was listed for in some ads. A couple things to remember: it should be the same car and the same year. So because a year affects the price too. So anyway, we're here. So example we did in class is, what if your parent came home and said, we got to get a different car, we're getting the same one we had. I found one that has 70,000 miles on it for $30,000. So one way for you to check that for your parent to help them, since you're learning statistics, is to plot a point. And I would plot 70,000 miles as my X and $30,000. And then I close that point. I can even label this Dad's car so I can see it. And this gives you a nice visual representation to say, you know what? I think, Dad, that might be overpriced from where it should be. We talked about how prices may vary. This might even be overpriced, but in these two cars, this might have something like nice rims or a nicer stereo system that somebody entered. This might have maybe a scratch or two. So having it be a little off the mark is understandable. But having it be this far off the mark, you'd have to really decide whether you're willing to do it, because this line of best fit, because of this R value, is a really good predictor of what things should be. The other thing that you may want to do is be able to enter things in right away and figure out what they should price. Well, for that, we're going to have to use function notation. And so we enter our function as f of x. And actually what I'm going to do is go really quickly to this, because y and f of x are the same. One's just a little more powerful, so I'm just changing that to f of x. Now, if I do it that way, this always has to stay as the line of best fit. Linear regression calculator has to use y1 and x1. But if we estimate and then use the f of x notation, you could now quickly do things by saying, well, how much should a car with 70,000 miles be? So I could type in f of 70. And when I do that, I should see this over here. Obviously, it doesn't have to be that exact price. That would indicate it's $19,430. That's what this point right here on 70 should be. But it does tell us, like, if something's 20,000, okay, that's cool. If it's 19,000, okay, that's cool. But 30, or what if we found one that had 40,000 miles on it? I would just type in f of 40, and then I see that f of 40 should be closer to $30,000. Well, I can look at the line and see that we're pretty close to $30,000 over here, right? So this is a way for you to be able to quickly enter data in to get back information once you've established that you can trust this line of best fit to give you fairly accurate information. And an R value of negative 0.867 we'll do that for you. Okay, hopefully that's helpful as well.